Guys, today we'll be talking about plotting the ship's position at sea using position lines obtained from the observation of the celestial bodies. When I say observation, that means when I have taken sextant altitudes of the celestial bodies, and I've got two position lines now, or two or more position lines, and now I plot the ship's position at sea to accurately know the position of my ship at sea based on the observation of the celestial bodies. Now in my previous video, which was titled calculating the intercept and the position line, all we learned was that using the intercept method we can calculate the bearing, the intercept and the position line. Now the ship lies somewhere on a position line. We don't know where unless we get another position line which intersects with the previous position line. So the intersection of two or more position lines then accurately give us the position of the vessel at sea. Alright. So in the previous video we just learned how to calculate one position line, but in this video here what we will learn is that if we have the two position lines, and I'll use a couple of different examples to show you how we can get two position lines, and then once we get two position lines, what to do with those two position lines and how can we plot the ship's position at sea. Alright, so let's take the first example here. This example, once I read this example, I'll draw a conceptual drawing of it on what is it that we are trying to achieve, and then I will go on to the plotting sheet and I'll show you how to plot the ship's position at sea. Alright, but before that, before I go on to the plotting sheet, I'll draw a conceptual diagram for you so that you can get the concept of what we are trying to achieve here. If you can't understand it on the first go, watch it a few times and I'm sure you will be able to get the concept of it. Alright, so let's take the first example here. In the first example, a vessel is steering 288 degrees true. Alright, and at 17.3 knots. At that point of time, there is an island called the 10th island whose position is accurately known to us, and it has been observed to bear 207 degrees true from the vessel. So there is an island, the position of which is known, is bearing 207 degrees from the vessel. So we don't know the ship's position, we don't know the DR position, we don't know the fixed position or the accurate position of the vessel. All we know is that there is a vessel which is steering 288 degrees true at 17.3 knots, at the time of which there is an island. The position of the island is known and it is being observed to bear 207 degrees true from the vessel. Alright, now 3 hours later, a meridian altitude of the sun, and we've discussed meridian altitude in my previous video, it gave a latitude of 40 degrees 32 minutes south. Alright, so this basically means that at the time of the meridian passage, when the sun was right on the observer's meridian, this vessel obtained a sextant altitude of the sun at the meridian passage and then derived the latitude from the meridian altitude of the sun. We have in our previous videos learned how to do that. We know already, so you can go and find my video where I've shown that how can a meridian altitude of the sun be used to derive the latitude at that point of time. So in this question here, we have to fix the vessel's known position. So that means we have to fix the vessel's position when the meridian altitude of the sun has been obtained and latitude has been obtained. So the latitude 40 degrees 32 minutes south then becomes my second position line. Alright, so let's see how can I get my two position lines. So to understand what we are trying to achieve here and how do we go about plotting the ship's position at sea, let me draw a conceptual drawing. Alright, let me draw a conceptual diagram here. So just bear with me for some time here. Alright, so what we have here is the 10th island, for example. This is the 10th island. Alright, so let's say the center of this cross here, or the plus sign here, is the 10th island's position. This is the 10th island, the position of which is known, right? This is given to us as 40 degrees 56.6 minutes south and 146 degrees 59 minutes east, right? All we know is now that the vessel is bearing, rather the 10th island was bearing 207 from the vessel. So that means if I look at it from the 10th island's point of view, the vessel will be bearing 207 minus 180, that is 180 degrees diametrically opposite to the bearing. So from the 10th island's perspective, the vessel will be bearing 0 to 7. So the vessel is lying somewhere on this bearing line. So this bearing line is 0 to 7 degrees. Alright. Because the diametrically opposite value of 0 to 7 027 plus 180 is 207. So the bearing was 207 from the ship's point of view, but from the 10th island's point of view, the position of which is known, the 10th island's position is known. So we need to use 10th island as a reference point because we don't know the ship's position, right? So we need to use the 10th island's position as a reference point. So it means that the 10th island's position, or rather the 10th island's perspective, the ship is somewhere on this bearing line of 027, but we don't know where. If we probably had a distance, we could have plotted the distance and known. So all I know is I've got a bearing line, and that's all I can draw. So I'll just draw a bearing line and put an arrow here. I don't know how long this bearing line is. Maybe the ship, it can go on, maybe more. I'm not really sure. At this point of time, all I know is it's a bearing line and the ship is somewhere here. To know where exactly my ship is, I need another position line. Alright. So I draw this position line with single arrows. The reason is that the first position line is drawn through single arrows. Now apparently, the ship has now traveled 20 on a course of 288 degrees true, right? And it has traveled at 17.3 knots for 3 hours, which gives me a distance of 51.9 nautical miles, right? So if I transfer this position, and if I, instead of taking the ship on a course, if I take the island on this course and I keep the ship on the same kind of a parallel movement as the island, because I don't have the ship's accurate position, so I have to basically move the island in reference, or rather in respect to the course and the speed, because since I don't know how the ship is moving, because I don't know the ship's position, I move the island on a course of 288 degrees true, something like here. Okay, it should be a straight line of 288 degrees true. Just assume this is 288 degrees. All right, so this is 288 degrees true. And I move it till I reach about 51.9 nautical miles. All right, this is where my ship will be after 3 hours. After 3 hours, for example, let's say this is 51.9 nautical miles, and this is where my ship is. So then now my ship is here now, right? But my ship is not here. The island has moved with respect to the ship, right? So my ship would be again somewhere here on a bearing of 207, and this time I draw double arrows because I have transferred this position line, has been transferred here. I have transferred this position line because my ship is moving with respect to the island here. All right, not in reality but in concept. All right, I'm moving the island and not the ship because I know the island's position, right? So once I have transferred it, if I can get another position line, the intersection of these two position lines will now give me my vessel's position at noon. And what is the second position line? I told you before, the second position line is 40 degrees and 32 minutes south as the latitude at meridian passage, right? Because this is an accurately known latitude based on sextant altitude. So if I can calculate this latitude here, if I can calculate this latitude here in reference to this latitude, I can then draw my other latitude. It could be here, it could be anywhere, but I'm assuming it's here. And why I'm doing that is because I've kind of already worked out this question, so I know it will be somewhere here. All right. Now the intersection of these two position lines then give me the ship's position, right? And I'll show you how the working is done. Now on the plotting sheet, we don't work out the whole question like this, because if it's 51.9 nautical miles, it's too much of a distance, and if I try to plot it on a small plotting sheet, on an A4 or an A3 plotting sheet, and if I use the scale of 1 centimeter equals 1 mile, then it becomes too much of a plotting. So for the plotting, what we do is we take a shortcut. I'll show you how to do that shortcut, all right. But what we focus on is, and I'll show you what we focus on, we delete all this here. That's right, we delete everything here. We just focus on this part here, right? So this part here, and this is what we draw on the plotting sheet. And now I'll transfer you to the plotting sheet and I'll show you what is it that exactly we'll be doing based on this concept here. All right, but before that, let me show you the shortcut that I talked about, right? So how did we take the shortcut? Let me show that to you. All right, so just bear with me. So what I basically did was I knew the course, right? And again, I used the concepts of plain sailing. Now if you don't know or you don't remember what plane sailing was, go and watch my video on plane sailing and you will see that what I did with plane sailing and how do we use plane sailing and the concept of plane sailing. Right, so I know my course. I got my course's notation, north 72 degrees west. This is same as 288 degrees true. Why I need that is because I need to name a d lat and a d long. And then I've got my distance as 51.9 nautical miles. I've explained that to you already how I do that. Alright, I've got the dr position, rather the position of the 10th island. And now I'm going to move the 10th island in respect to the ship. Because I don't know the ship's position, what I do is I apply my course and speed and distance to the 10th island's position and I move it in reference to the ship. Something that we did in the conceptual diagram. I showed you that I'm moving the island instead of the ship. I'm moving the island in reference to the ship. Now if I can apply the course and distance and I can calculate my d lat and d long, and over here I have shown you how to do it. I'm not going to repeat all this, is because this is same as the plane sailing. If I know a position and if I know the course and speed, I should be able to, or rather the distance, I should be able to calculate my final position. If you don't remember this, watch the video on plane sailing and see what I do. But I have shown you the working here, how I calculated my d lat, what was the formulas I used, and the m lat calculation, the departure calculation, and then using the departure to get my d long, which I have then applied over here. So once I calculate, I apply my d lat and d long, rather my course and distance, to the known position of the 10th island, I get something known as an estimated position. Now all this is why I'm using this is because these are estimated positions and dr positions of the ship rather, but although I'm moving the island, I cannot say that these are accurately known positions because this is not the position of the ship. These are the positions, these are the estimated positions, these are the dead reckoning position, because I still don't know what is the fixed position of the vessel. I don't know it accurately, right? So that's why I'm using all these terms. So once you apply the course and the distance to the island's known position, you can then move the island in reference to the ship and you can estimate where the island would be after 3 hours. And this is the position where it would be after 3 hours. 40 degrees 40.6 south and 145 degrees 54 minutes east. Right? Now this is the shortcut. So I have moved it and I have not had to plot the 51.9 nautical miles. I didn't have to draw my course of 288 degrees true. I have moved the island applying the principles of plane sailing. Alright, so let's see what I'll do from here. I go into my plots. Alright, now I have to find out where my plotting sheet is. Here it is. Right, so my plotting sheet is here. If I turn it around a little bit, hopefully it will help you understand it. Yes. So what I do now is I've got my estimated position, remember? So I've got my estimated position. So I need to get my marker now activated. And I'm wondering, why can't I do it? Now I've done it. Sorry about that, guys. Just bear with me here now. Alright, so now I have got to do my plotting. Now what I know is my estimated position, right, of the island. I put that on the center of the plotting sheet. So the center here, the circular center here, this one here, this center here, right? The center of this position here, the dot here, becomes then my estimated position. So what I'll do is I'll draw a little bit of a cross sign here. This position becomes my 40 degrees and 40.6 south, right, and 145 degrees 54 minutes east. This is my estimated position, EP, of the island. I have moved the island. Then what I do is I draw my bearing of 207, or rather 027, because that was my bearing of the ship with reference to the island. I've transferred my position line as well. So what I'll do is using a scale, I must get a scale now, isn't it? I had a scale somewhere here. Here it is. So what I'll do is I'll draw it so that it's a bit accurate. Otherwise, it's always I've drawn ugly diagrams here. This time I want to draw a nice one for you guys. Still I'm not doing a good job here, so I must erase this. I want to do a good job this time, guys, so bear with me. Let me draw a 027 for you. So this is my 027. That's right. Okay, this is better. Alright, so this is my 027. I am somewhere here. I don't know where I am, but I'm somewhere on this bearing line, and I'll denote it by double arrows because I've transferred this position line. Right? Now once I've got that, all I need is my second position line, which is 40 degrees and 32 minutes south. And that 40 degrees and 32 minutes south, remember 40 degrees and 32 minutes south is our latitude from the meridian observation given to us in the question. Latitude, meridian passage, I'll write it down just to remind you where I got that value from. This is given to us in the question. Now what I need is basically I need to plot this latitude. I can plot it, right? Because I've got one latitude here, which is the estimated latitude. I know that this is somewhere 8.6 minutes north of me, right? So if I use a scale of 1 centimeter equal 1 minute, or you can use this scale as well. You can use a different scale, but make sure that you let yourself in this case here, you should know what scale you're using so that you can apply that scale to all your calculations there. All right. So the latitude of 40 degrees 32 minutes would be 8.6 minutes north of the estimated positions latitude. All right. So if I draw it to scale, it will be somewhere, I have to go somewhere absolutely perpendicular of me. I'll go somewhere here, right? And if I take a .6, so why not I use this scale here so that I can get some intersections here. So if I draw it to scale here, I need to extend my plotting sheet. 8.6 will be somewhere. Okay, so I'm using the, that's right. So if I draw a perpendicular line here, that's it. So what I'm doing is I'm using this scale here. I'm using this scale, right? So this is where I draw. So this is about 8.6 centimeters based on this scale here, and this is the where my latitude lies, 40 degrees 32 minutes. So what I'll do is I'll draw absolutely a parallel line to the center line, and I draw this parallel line here. If I can draw a parallel line, right? That's right. Alright, so this is 40 degrees and 32 minutes south. This is 40 degrees 40.6 minutes south. Alright, so this is how it will be given to you in the chart as well. In the chart you won't have to measure it, you will know where your latitudes are, but in the plotting sheet, yes, you have to do it. So, and now if I extend this position line here, there is an intersection that I get, right? This intersection here is giving me the vessel's position. This is the fixed position, right? Now what do I do with this fixed position? I know the latitude already. All I need is the longitude. So basically this distance here will give me the departure. The departure in this case that I have measured is about 4.6 centimeters. So this means 4.6 minutes. And now what I'll do is I'll go back to my calculating sheet, right? I'll go back to my calculation sheet and I'll show you what I've done with this departure. So once I have got my departure from the plot now, 4.6 centimeters, this is the one. I know my two latitudes, so I can calculate my m lat or mean lat between the two latitudes, and this is my mean lat here. I just calculate my d long using the formula departure divided by cos of mean lat. I get my d long. It's east because the fix was further east of the longitude, right? So that's why it's east. If it was on the west side of the estimated position, it would be west, but it was on the further east side of the estimated position, so that's why it's 6.1 minutes east. So when you draw the plot, you will see that your fix is on the east side of the estimated position, so that means your longitude should be increasing eastward. And then all you need to do is just apply it here. I've added it here because you're going further east. You know the latitude already at noon because it was given to you. All you needed was the longitude, and now you found out the longitude. Right, so it's that simple. So the concept is a bit complicated maybe for you guys, but hopefully if you watch the video a couple of times, you will get an idea of what it was all about, right? So how I shifted the island with reference to the ship because I didn't know the ship's position. If you know the ship's position, then you of course do the same thing with the ship's position. You basically take the ship's position, you put it in the dr position here, and then of course you apply the course and distance, but you always use a shortcut because you can't do the whole plotting on a plotting sheet. You can do it in the chart. On the chart, of course, it's a big chart, and you can do it, but I don't have the chart here to show you, so that's why I'm using the plotting sheet. So in the plotting sheet, we use a shortcut, and we use the principles of plain sailing, and so that's how we do it. All right, so let me take you another example. Let me show you another example where this is a bit of a different example here. This here you have to do the plotting using simultaneous observations. So that means your vessel was in a DR position that is known to you. It's the dead reckoning position, and you used the vessel's position at that point of time to obtain 3 intercepts and bearings. The 3 are given to you here as A, B and C. So you've got 3 intercepts, so you've got 3 position lines now, and you've got the bearings of each of these position lines, and you would have to calculate, or rather fix, the vessel's position at sea from there. Alright, so you get the question. So basically now you didn't steer on a course and speed or anything like that. You didn't do anything like that. What you did was you were at one position, the position of which was not accurately known to you. It was approximately known to you as a DR position, and then what you did was you obtained 3 intercepts using maybe 3 different celestial bodies. It could be 3 stars located at different angles, and now that you've got those 3 intercepts, now you're going to plot the ship's position. Alright, so let me show it to you how to do it. So I'll go straight to the plot. Alright, the first thing I do is I get rid of all these things so that you don't get confused, and you can use the same scale again here because the scale works for me, and you can use a different scale if you have a plotting sheet on the ship. If you have a chart, then of course you don't worry about the scale. You use the same scale as that of the latitude scale. You always use the latitude scale. Now here, if the plotting has to be done, all I need to know is the DR position which is given to me. So the center of my plotting sheet here, the circular center, becomes my DR position, right? So I'll plot the DR's position here. This is the DR position, which is given to me as 20 degrees 11 minutes south and 140 degrees 36 minutes east, right? Now from here I have to plot 3 positions, rather 3 intercepts and 3 position lines, right? So what I'll do is, this is the DR position. Now you know that this is the DR position. I'll erase it because I need to do some plotting and it will become all cluttered. So let me erase it. You know that this is the DR position now in the center. So what I will do is just I will draw a plus sign here, so I know this is the DR position, and now I need to do some plotting. So my first plotting was that my first value given to me was an azimuth of 042 degrees true and intercept of 3.2 away. So what I do is, because it's away, I don't go towards 042, I go away from it diametrically 180 degrees opposite to it, and which would mean I have to go in a direction of 042 plus 180, that is 222. Yes, so I go in a direction of 222, and if I can do a good job again for you guys, hopefully I can. This is 222, right? Somewhere 222, and I'll plot 3.2 based on the scale here. I'll plot 3.2, the scale that is given to me here in this question. That's right. So this is the scale I'll use, 3.2, and I'll plot the intercept here. Alright, because that's what they want me to do. So somewhere here, and then I draw a line perpendicular to my bearing line. Okay, so make sure you draw a line perpendicular to the bearing line. Now this is also your position line. Alright, so if you add 90 degrees to it and then subtract 90 degrees from it, you will get the position lines orientation. So in this case it will be 132, and of course if you subtract 042 from 90, you might say it is minus 48. It doesn't work like that. So what it does is, basically what you can do is then you go to use the 360 degree principle, or just add 180 to this here, to this value here. Alright, so then this becomes 312. So this is how you get the position. So this line here is in the orientation of 132 and 312. Alright, so that's the whole concept. I have explained all this previously in my other videos, but I'm just showing it to you so that it's a good reminder for us, right? Every time we learn, we should just remind ourselves of the previous concepts as well. Alright, so let me keep going, otherwise this video is becoming very long now and you guys, I'm sure, are getting very bored. Alright, so my next azimuth is 100 degrees true and 5.6 minutes towards. So I need to go towards 100 degrees true, and this is what I'll do here. I'll go towards 100 degrees, right? And I need to plot 5.6, which in this case is I'm going to get it, okay, I'm plotting it now. You guys can do your own plotting at the same time. There you go. I've got that here. I'm pretending to draw a perpendicular line here, so this is another perpendicular line, right? I'll extend this line as well because all these position lines need to intersect, right? So I need to extend this line as well. That's right. Got this one here as well. So already the two position lines have intersected. The third one should intersect as well. And now the third intercept is 170 degrees azimuth to and 8.2 towards, right? 8.2 towards. So I need to go towards 170 degrees and I do that, and 8.2, right? So I need to plot 8.2 and I'm going to do that here. This is my 8.2, right? And if I draw a perpendicular line now, you can see that, oh, it perfectly intersects, right? The three perfectly intersect. That's amazing. So this is the fixed position, right? This is the fixed position. And now what do I need to do is, let me erase the rest of the lines. Once you've got your fix, let me erase the rest of the lines so that I can show you what to do next. You already know, you have seen it in my previous plot, but let me show it to you, right? So what I'll do is I'll erase this line here, then I'll erase this line here, I'll erase this line here, and I've got my fix, right? Okay. Now what I need to do is, because I know the DR position as 20 degrees 11 minutes south, I need to, if I can calculate vertically, this is further south, right? So this is vertically further south, so all I need is to calculate this distance here, the one that I've just drawn, the perpendicular distance. So I am just calculating the vertical distance. So this vertical distance in my case here, all right, so my dlat is about 8 centimeters. So I'm 8 centimeters, that means my dlat is coming as 8 centimeters, which is about 8 minutes, and this is 8 minutes south of the position. So I know that my latitude will be 20 degrees 11 minutes south, and I'm going further south, so I'll add minutes to it, so this becomes 20 degrees and 19 minutes south. All right, approximately. You might get 18.9, somebody might get 18.8, depends on how thick is the pencil, what kind of pencil or what kind of scale you're using, but it should be somewhere very close to this. All right, and then once I've got that, if I can get this horizontal distance here, what is this horizontal distance? Is it d long? No, it's departure. All right, and what have we done in the previous video? If we know the two latitudes, we get the mlat, we've got the departure. In this case, my departure is measuring up to 4.2 minutes. So that's 4.2 minutes. So this is what I'll take, 4.2 minutes of departure, and I'll go back to my calculation sheet, right? So I've got my, from the plot, I've got about, okay, so I've got about 7.9. So on my scale it was coming about 8. So that's okay, 7.9. I've put in the 7.9 and I've added it because it's further south. I've got a departure of 4.2 and it's on the east side because my plot now fixed position is coming more further east of the longitude, of the DR longitude, so it becomes east. And since I get both these latitudes here, my initial and final, I can calculate using these two latitudes. I can calculate my mlat. Then using my mlat and using this formula here, I have got my departure. I can calculate my d long. My d long will be 4.5 minutes east because my fix is coming east of my DR position, and all I need to do is just add my d long to it in this case, and this gives me my vessel's position. Right, so we've used two different kind of examples and I've shown you how to do the plotting. These are the two kinds of plottings that normally you guys will encounter. So it's either simultaneous observations, or it's the first one is an example of a running fix. So we also call this something called a running fix, where a vessel goes on a course of course and then distance, and then we transfer the position. So I hope you guys have understood this. Watch these videos as many times as you want, pause where you can't understand, and I'm happy to receive any questions through comments. All right, thanks.